Okay, we're doing this problem about minimizing cost of a fence. So this is the problem. We have to build a fence that encloses a particular area. We know that the material costs $4 per foot on the north-south sides and $8 per foot on the other two sides, and we want to minimize the cost. Okay, so I have the information here, and I've got a drawing that will represent the enclosed area. So I've labeled the north and south facing walls as X and the east and west facing walls as Y. So whenever we have optimization problems like this, we have sort of a main equation, the thing that we're trying to optimize. In this case, that's going to be the cost. And then we have a constraint as well. Okay, so in this case, the main equation is the cost equation. So we need to figure out how much this thing is going to cost just in terms of both X and Y for now. So to do that, we first need to figure out what the perimeter of this thing is going to be. So let's call perimeter equal to 2x plus 2y. Perimeter just being the sum of all of the sides. Okay, and and then let's take that and figure out what the cost is going to be. So it says that for the north and south facing walls, it's $4 per foot. And how many feet do we have? We have 2x feet. So basically we just take the price per foot, $4, and multiply it by the number of feet that there are. So that's 2x. Okay, and then to that we add the cost per foot of the east and west ones, and that's $8 per foot. And we multiply that by the number of feet that we have, so that's 2y. Okay, and so that gives us 8x plus 16y. Okay, so what we're trying to do is minimize C, the cost. Okay, and then we have a constraint as well. Our constraint is that the area of this thing has to be fixed at 45,000 square feet. So the area, 45,000 feet, that's the constraint. And we can actually define the area even more specifically than just A. Area of any rectangle like that is just the length times the width, so that's just x, y. Okay, so what the constraint is going to do for us is it's going to allow us to eliminate one of the two variables in the cost equation. Okay, so we can solve this for either x or y. I'll go ahead and just solve it for y. So y is equal to 45,000 over x. 45,000 over x is y. And now we can write a cost function, and we can actually say that it is now going to be a function of x alone, c of x. Okay, so that's going to be 8x plus 16y, but we just figured out what y is. Y is 45,000 over x. I'm actually going to write this as 45,000 x to the minus 1 power. It's going to make it easier to take the derivative of this thing. So that's going to be 8x. Let's simplify this a little bit. 16 times 45,000, put that in the calculator, is 720,000. So this is going to be plus 720,000 x to the minus 1 power. Okay, now remember the idea for all of these problems is to minimize or maximize, in this case minimize. That minimum or maximum value is always going to occur at a critical number. Okay, so we need to find the critical numbers for this particular function, so we do that by taking the derivative. So c prime of x is 8, and then this one we bring the minus down in front, so minus 720,000 x to the minus 2 power. And we can simplify this a little bit. We can write it as 8 minus 720,000 over x squared. Okay, now to find the critical numbers, remember we need to set that equal to 0. So, in fact, I'll just do that right here. Set that to 0. That means I can move one of these to the left side, one to the right side. Let's leave the 72,000 on the, well, let's move that to the right side. So we'll get 8 is equal to 720,000 over x squared. We can multiply both sides by x squared. So we get 8x squared is equal to 720,000. Divide both sides by 8. We get x squared is equal to 720,000 over 8. And that is 90,000. And then finally we take the square root of that. So x is the square root of 90,000. And that is 300. Okay, so that's telling us that if x is 300, then that will minimize the cost. Okay, and let me just make sure what the question is actually asking us here. It says find the cost of the least expensive fence. So what we need to do is take this 300 that we just got. This is the, remember the length of this side here. But that's not what they're asking for. They're asking for the minimum cost. So what we have to do next is plug that value into the cost function, and we need to find C of 300. Okay, so if we plug that into the cost function, we'll get 8 times 300 plus 720,000 over 300. Remember that the cost function was this one here, well, right there, but the x to the minus 1 is just the same as having the negative, or the x in the denominator. So if we plug that in, we get, let's see, 8 times 300 plus 720,000 over 300, and we get a cost of 4,800 dollars will be the units on this thing. Okay, so that is the minimum possible cost to make this fence with these requirements here, that it has to enclose 45,000 square feet and the cost of these as written. Okay, now in some of these problems what you might see is that they also take the second derivative of the function and then plug this number into the second derivative. The purpose of that is just to verify that what you have is really a minimum value. So if we did take the second derivative of this, what we'd find is that when we plug 300, we would get a negative, or sorry, we'd get a positive value, and that would mean that it's concave up at the critical number. And since it's concave up at a critical number, that makes it a minimum. Okay, so that's the only purpose of taking the second derivative of a function like this. We can pretty much safely assume that that's going to happen, that we're definitely going to have a minimum value here, so it's not really 100% necessary to do that second derivative check. Okay, this is definitely the answer. Okay, so I just wanted to point out that that's why sometimes they want you to take the second derivative and also verify that you have either a minimum or a maximum value. Alright, and if the question actually asked you for more than this, like, well, there's the minimum cost, we already had the x value, how long is that x going to be? We could also then find the y value if they asked for that as well. How would we find the y value? Well, we have this equation up here, right? We could just plug in the x that we got, and then that would give us the corresponding y value. So if they asked for the dimensions, then you could give those as well. Alright?